In the past, there was a general thinking or belief that the rules that govern the heavenly bodies may be different from the rules that govern the bodies on earth. It was proposed by Newton that the force due to which moon revolves around the earth is actually of the similar type, the force that earth applies on apple, for example. A lot of work was done before Newton in trying to understand the planetary motion, and one very important name in that connection is that of Kepler. We will discuss Kepler's laws later on, but those laws helped Newton. Kepler's laws were about the motion, planetary motion, but connecting something which was believed to be heavenly to something that happens on earth, pulling the apple. That was a big achievement, and it is said that Newton got this idea while he was sitting under an apple tree and one apple fell down. So he suddenly got this idea that is it not the same type of thing that happens to moon also, and that makes moon fall towards earth. Moon falls towards earth means because of the motion, moon is not literally falling, but the force that earth is applying on the moon is providing the centripetal force. So you can that way say that moon is falling towards the earth, but because it has got speed, it literally does not fall, but keeps on revolving. If moon were not falling, how could it go round and round? It could have got liberated from earth and would have gone somewhere else. So this idea that every object attracts other objects, because once the things are linked this way, that moon is attracted by earth by the same type of force that earth applies on the apple, then you have a general law which works between any two bodies. If earth is applying some force on the apple, then from Newton's third law, apple will also be applying same magnitude of force on earth. And if earth applies some force on moon, then moon would be applying equal and opposite force on earth. So now if you extend this to any two bodies in the universe, then you have got a general law of gravitation. So taking help from what work was done before and what was known in physics, Newton was able to propose this particular law, F equal to G mm upon r square between two particles, capital M and M, and this is the attractive force that capital M applies on small m, and small m applies on capital M. It is equal and opposite, following Newton's third law. It does not require any medium, and it does not depend where those two masses are placed, because capital G has a fixed value. So where they are placed is not important. If their distance is something, then you place them on Earth's surface or Moon's surface, or they can be anywhere in the universe. The force between them is going to be the same. This law also works for spherically symmetric, spherical uniform objects like planets. Now, they may not be 100% uniform, but with approximation, it's okay. So it is for point masses. It also works for spherical uniform mass distributions. And here m's, these masses, and think about that mass, F equal to ma type of mass. The m's that appear here are called gravitational masses of the body, and the m that appears in F equal to ma, that is called the inertial mass of the body. When we talked about Newton's laws of motion topic, then we talked about F equal to ma, where m was that m. And that m is called inertial mass because it tells about inertia, tendency for a body to oppose the force, oppose its velocity, let's say. Tendency of a body to oppose its velocity. So it was an indicative of inertia of the body. So that was inertial mass. And now we are saying that two bodies attract each other by this much force. Then these m's are called gravitational masses. But there is no experimental observation to suggest that they are different. Gravitational mass and inertial mass, there is no experimental observation to suggest that they are different. So we consider them one and the same, gravitational mass or inertial mass, and we just say mass. G has fixed value and it does not depend on the medium. And this value is given by 6.67 into 10 to the power minus 11 in SI unit. It is called universal constant. You come across many constants in physics, and some constants do depend on the medium. Light passing through glass is not same as glass passing through water. Its speed changes. Then You are aware of certain materials being magnets and some materials are not magnets. So magnetic behavior depends on the material. This G does not depend on the medium or the place. So it is universal constant. The unit of G in SI system can be found out very easily. Force into R square by mass square. Newton meter square per kg square. Gravitational force is a conservative force, which means that it does not dissipate energy, and therefore we can define potential energy associated with gravitational force. If you remember, potential energy can only be defined for a conservative force, not for non-conservative or dissipative force. Why this force acts is not understood yet. Talking about potential energy, we defined potential energy earlier, and we defined it like this. So it's nothing new really. We are just going to take further from there and apply it for this particular discussion. Delta U equal to minus WC. That's how we define potential energy, or rather change in potential energy. You have been using this result mgh for long, and that mgh works only for short distances near the surface of the earth. You can't use mgh if you are talking about reaching the height above Earth's surface equal to the radius of the earth. I mean, then G would not be the same G, 9.8. G will change if the height is so much. So mgh result that we have been using in another topic, work and energy, in that topic, whatever was going on near Earth's surface. So mgh was fine. But now it's not fine in all cases. When you are dealing with what is the potential energy of Earth and Moon system. Now imagine for a moon, can you use mgh? And then when we derived mgh formula, then Earth was not supposed to be moving. Only that object was moving. Now when we have two big bodies, two stars, two planets, planet and star, in those cases we need to use something else. That's exactly what we are discussing now. Potential energy for two bodies system. Say Moon and Earth system. Potential energy is always for a system. So while mgh we often say is energy, is potential energy of some book or some particle near Earth's surface, strictly speaking it is the energy of the Earth, that object system, mgh also. It is the energy of the system. So now suppose we are looking at two bodies, big bodies, two planets, two stars. For this system, what is the potential energy for this system? So delta U is equal to minus Wc. We will talk about particles, but as I said earlier, for spherical uniform symmetry, the discussion would be applicable for outside points. And most of the times we are interested in outside points. What happens outside Earth? What happens outside Sun? But we will begin with particles. Let's say there are two particles. For this system, we want potential energy. Now, let's say M2 is taken from R1 to R2. R1 to R2. It was at R1 distance. Now it is taken to R2 distance. And what you are seeing right now as M2's position is the instantaneous position, call it R, at some instant of time in its journey. Obviously M1 is pulling it, but M2 is going to the right. So some external agent must be applying force on the right side. That's why it is able to reach. Now, delta U is minus Wc, and work done by conservative, this is Ci actually, conservative internal. Internal means once we define our system is M1 plus M2. Then this must be internal force, work done by internal force. So what force M1 is applying on M2? That is the internal force, it is conservative force because it is gravitation. So force is G M1 M2 by R square at any instant. And now imagine it travels by dr to the right side. Force is on the left side, dr is on the right side. So work done would be F dot dr. Dr vector is on the right side, force vector is on the left side. Now, I am talking about little movement dr, so it should be little work dw. So it is minus G M1 M2 by R square dr. So little du is minus, little du is minus little dw. Minus dw, and that is G M1 M2 by R square dr. That means U is integral of this whole thing, and that goes from initial position to the final position. Here also U delta means final U minus initial U. Imagine here also you have put limits U1 to U2, U1 to U2 on the left side also. That I have done directly. G is constant, M1 is constant, M2 is constant. Integral of 1 by R square is minus 1 by R. From R1 to R2. So G M1 M2 1 by R1 minus 1 by R2. So that's U2 minus U1. In case of Earth and body system, how did we get mgh? We must have taken some reference point. Reference point. Here, when we are dealing with two heavenly bodies, then you normally take infinity as your reference. But that's not necessary, it's a choice. So if the distance between them is infinity, suppose that I choose as my reference potential energy or zero potential energy. I have U2, that is UR2 minus U1 or UR1, and that is equal to GM1M2 1 by R1 minus 1 by R2. When R is infinity, I am choosing U to be 0. That's by choice. Some point we have to take as our reference point. So UR2 minus U infinity is G M1 M2 1 by infinity minus 1 by R2. By choice U infinity is 0. 1 by infinity is anyway 0. Dropping the subscript 2, UR is minus G M1 M2 by R. So now it is not MGH. You shouldn't be thinking about MGH when you are thinking of two big bodies. This is the formula you should be thinking of. It is the energy of a system of M1 and M2. But then there will be several occasions when there are more than two. Say 3 stars are like this. What is the potential energy of this system of 3 stars? You will take 2 at a time. You will take potential energy of this system, this system, this system, 2 at a time. Every pair that you can form. If there are 3 things, number of pairs you can form is 3C2. These many. 3 pairs basically. And potential energy is a scalars. That means between these, if it is U1, between these, if it is U2, and between these, if it is U3, then U for the system of the 3 would be as simple as numerical addition of these 3. Any questions? If you have up to this point, let me know. So what's the answer? Just think for a moment. How is it possible to have such a large acceleration for Earth? .8 is big for Earth. We are getting that much acceleration because somebody like Earth is pulling us down. something as big as Earth is pulling us, so we are getting 9.8. How can apple, insect, these small fellows give Earth that much acceleration? Okay, the answer is trees on the Earth itself, not anywhere else. The answer is pseudoforce. Insect is an accelerating system. Insect is accelerating with 9.8 meter per second square acceleration. Insect is no longer an inertial frame. So if you want to understand things from insect's point of view, then you must apply pseudoforce. If the observer is accelerating with a acceleration, how much pseudoforce should be applied by the observer? Mass of this thing into acceleration of the observer. I hope it is clear now. If there is any question, then let me know. Yes, any questions, let me know or we move on. Distance is to be taken from the center of the Earth. So if the body is here, this is R, then from the center it will be 2R. So from the surface, 1 upon R1 minus 1 upon R2. From the surface to this point in one case, from the surface to H in the other case. See what you find. R by 3. Let me know if you have any questions. Some options are given, but even without them, you should be able to tell the answer from conservation of mechanical energy. Assume that the bodies are spherical in shape so that you can use that result which we have derived. First you try. Check your working again. Let me discuss it on the board. Initially at rest. Since they are at infinite distance, let's take potential energy when they are at infinite distance to be the reference, 0. When they are r distance apart. Now this force is internal force. So how can linear momentum change? Both are at rest. Now minus sign only shows that V1 and V2 are in opposite directions. You can just take mod. Right, minus sign only shows the direction, opposite direction of the vector. Magnitude wise, minus sign is of no meaning. Now, we want relative velocity. They are in opposite directions. They are moving in opposite directions. So relative velocity should mean V1 plus V2. V1 plus V2. Now it should be possible to solve further. But if you still have a problem and you would like me to continue, then raise your hand. Now, m2 v2 square I am going to write as m2 square by m1 by m2 multiplying by m2 dividing by m2. So it gets us m1 v1 square plus m1 square v1 square upon m2 equal to twice g m1 m2 by r. Now you can get V1 easily. If you can get V1 easily, you can get V2 easily. And then you add the two. So now you should be able to proceed. The answer I have is see if you are getting it. Answer looks quite simple. And let me know if you are not getting it. So I suppose you are getting it. Any questions regarding this, let me know. Fine. No assignment for today. We stop now.